Hello and welcome to yet another OpenShift Commons briefing. This time we have Rob Zumsky from the OpenShift team, formerly from the CoreOS team, who is going to talk about the operator framework that we've just recently open sourced and give us an overview of the whole thing. I'm going to let Rob introduce himself and his topic. The format for this is we have a chat. You can talk amongst yourselves via the chat during his presentation, and then afterwards we'll have some live Q&A. So please, let's let Rob get started here. All right, take it away, Rob.
Hi, everybody. Thanks for joining us today. As Diane said, I am formerly from the CoreOS team and have been around since 2016 when we introduced the concept of an operator. And today I want to talk through kind of the next iteration of that, which is the operator framework. And this is the culmination of all the knowledge that we've learned from introducing that concept and how it's kind of flourished in the community. And this kind of brings all of those best practices into one way for everybody to get started with an operator. So the agenda today is to talk through just what an operator is, give you an intro to the concept, talk about specifically what does an operator do. We'll look at some real-world examples of operators that exist today, and then how you can use the operator framework to make one for yourself. And then kind of wrap it up with a touch on security and why operators are key to that. And then we'll have a live Q&A. And I believe we have Mike from Couchbase on the line. He has some experience using the SDK. So if you have questions about real-world uses of that, he can field a few questions there. So with that, let's get started. So as I mentioned, what we're here to talk about today is the operator framework. This is an open source framework. It's available in a new GitHub org called operator-framework. And we're going to talk through what that means in a little bit. But first, let's talk about just what is an operator? What is this concept? And an operator is just a method of packaging and deploying and managing a Kubernetes application. On the right here, you can see that, say you want to deploy an etcd cluster. This is a distributed database, so there's a lot of coordination that needs to happen. If you have, say, 5 members of that database, they communicate securely, and you can run that on Kubernetes. What the operator does is provide you a way to version and package and then deploy that etcd cluster and dynamically spin up all 5 of those database instances on top of your Kubernetes cluster. Same thing for Prometheus. Same thing, it needs to be versioned. It has a number of distributed components that all need to talk to each other. There's configuration, there's scaling, and the operator allows you to encapsulate all of that knowledge. This is something that if you were going to just deploy, say, a distributed database or a big Spark cluster, whatever it is, manually you would be following some sort of runbook. You might have a script. You might just have knowledge in your head about what to do, which components to bring up first. And the operator encapsulates all of that into a method where you can package and deploy that. And so you can give somebody a single artifact that says, hey, this is how you can deploy a Couchbase cluster, a Prometheus cluster, an etcd cluster, and then quickly get that up and running on your Kubernetes cluster. So the key thing about operators are that they are using a blessed mechanism inside of Kubernetes for extensibility. And this is, I'll call, quote-unquote, kube native. And this is really important because you can use all the Kubernetes tooling to install, manage, and deploy operators onto your cluster. And the crazy thing about this is that it allows you to plug in a new type of object into Kubernetes. So say you've got your application and you want to provide that application out to other users of the cluster. Kubernetes has this extensibility mechanism where you can say, I want to create a new object called Couchbase, for example, and now a Couchbase cluster is something that you can use the kubectl command line tool or use the API to instantiate because of the mechanisms built into Kubernetes. Now, where this contrasts with something like a public cloud, for example, you can't provide a service called etcd cluster to the rest of the Amazon ecosystem, but you can if you're using one shared Kubernetes cluster or a set of Kubernetes clusters internally at your organization. So that is really, really, really powerful to be able to give folks access to these higher level primitives, and then the operator has that knowledge of how to actually deploy, manage, scale, back up that application And so you as a Kubernetes end user are just instantiating a new object type to get a new couch-based cluster. And another beautiful thing about using this extension mechanism inside of Kubernetes is that you now have a really great hybrid cloud story for instantiating a couch-based cluster, a Prometheus cluster, an etcd cluster across a number of Kubernetes environments. So if you're running OpenShift across bare metal on all the different cloud providers, this operator is going to work the exact same. And so if you want to deploy an application modeled with an operator on any of those clusters, as long as you have the correct permissions, it's going to go through just fine. So that's kind of why you would use an operator in the high level, but what does an operator actually do? And the real simple version of it is you want to take a declaration of what an application is. This is what you can see on the left-hand side. This is typically a YAML file of a version of an application, maybe some light configuration, and we'll look at some examples of what that is in a second. And then there's this magical piece of software in the middle, the operator, that is going to parse that and then turn it into a number of Kubernetes objects. If you think about any sort of distributed system, you're not just going to have application pods running, but you're going to need to maybe set up pod autoscaling. There's going to be configuration values that need to be set maybe in a config map, generate TLS secrets and store those as a secret in Kubernetes. Maybe set up a new database that's a dependency, and that might be running in pods with its own configuration and secrets and stateful sets. So the operator sits in the middle of this and translates this really simple high-level representation of a distributed application and then translates it into Kubernetes objects. And what this looks like is there is a loop running, referred to kind of as an OODA loop, observe, orient, analyze, and act. And this is the main logic tree of an operator. And where this is important in modern distributed systems is that this is a declarative state, just like any other object inside of Kubernetes. So if you have a deployment, for example, you set the desired state of I want 5 replicas, and the system will analyze that and say if there's only 3 running, I need to start 2 more. That same method is used to represent these higher level configuration options for an operator. So for example, in an etcd or Prometheus cluster, you would say, I want 3 replicas of this, make it happen, or I want to upgrade from version X to version Y, make it happen. And the operator has all the knowledge for what to do to actually make that. And as I mentioned before, the important thing is this is a native extension point for Kubernetes. So this will work against any Kubernetes cluster, and this is how the Kubernetes cluster is going to be able to plug in and have these new object types. And what this means is you're not having to fork Kubernetes to add new functionality. This has been architected into Kubernetes from the beginning. And so that's really important to stay on that upstream path and have a nice story for working across all the different Kubernetes providers. At CoreOS, we've used operator functionality since it was introduced to enable over-the-air updates of components of a cluster. We've done some crazy things like even update Kubernetes itself with an operator. And so we think this is a huge win for security and automation, and we're going to touch on that in a second. So let's look at a really easy example of an operator, and that left-hand side that we talked about earlier, the declarative manifest, is actually a custom resource definition in Kubernetes, and this is how you can add custom resources. So this is what an etcd cluster CRD looks like, and you can see at the top, this looks like any other Kubernetes YAML file that you might be used to, except for the kind is now our custom resource, the etcd cluster. And it can have all the common Kubernetes metadata, name, annotations, all that good stuff. Here we've got a name of example. And the spec is where the magic comes in. And a spec in a typical thing is the custom thing that is used to drive that object type. So in a deployment, you model the number of replicas in your rollout strategy. And here we have a completely custom thing for etcd. So we have the size of the cluster. We also have the version of the cluster. So notice that you're not putting in the complete image strings for where the container is being stored on a registry. The operator has all that logic built in. And so that's a pretty simple example. So if we submitted this to a Kubernetes cluster inside of a namespace, we would get an etcd cluster that would have 3 pods running version 3.2.13. But let's look at a little bit more of a complicated example. And this is kind of a fake one that goes a little bit further and shows you how smart one of these operators can be. And what this is looking at is an object for a magical compliant database. So these days we've got GDPR and all kinds of data locality concerns. And let's imagine that we have a piece of software that is knowledgeable about this. And it's knowledgeable even maybe about multiple clusters and geographies. So here we're going to instantiate a new compliant database. It's got a name of example.db. It's a replicated database, so it's got a replication factor. We're going to dial that up to 2. Yes, we want to auto-scale it, so as more data gets ingested, we might need to run more replicas, and so the operator knows how to instantiate those. Yes, we want to back it up hourly. And then the magic part here is this geography. Now, once again, this entire spec parameter can be customized, and so here we've got 2 different subkeys for geography. We have a restriction, and this is where we say that everything running in this database needs to be stored in the European Union. And then we have a preference, though, for Germany. So imagine that you've got a number of clusters, maybe one running in Belgium, one running in Germany, one running elsewhere. And if any of those clusters are having issues, the operator, with its smarts, remember, it can follow the runbook that you would typically have to execute, but it's built into its logic tree. So if your German cluster went away, it could move it to Belgium and still be within that geographic restriction, but maybe your preference due to speed is not actually honored. And so this shows the scale of what you can accomplish with an operator. You can think about modeling any sort of application this way, and the high-level primitives that you get to expose are completely custom to you in this YAML file. Now, remember, we talked about being kube native is really important, and this is a blessed extension mechanism. And this makes the best ecosystem. So if you're thinking, oh, I already have methods for deploying my software, why do I want to tackle this? Why do I want to build an operator? It's because you get access to the entire Kubernetes ecosystem of users if you are kube native. And if you happen to be building an operator for either an open source project or commercial software, being kube native is a really great way for sales enablement, because now you can sell to the entire Kubernetes user base, and operators provide a really great experience for having something, user experience that feels very cloud-like. And so that's a really, really great value prop for you to use and go out and sell. So let's look at some operators that are available today. The top 3 are ones that we've worked on at CoreOS and will continue to work on at Red Hat. These are etcd, Prometheus, and Vault. And then the bottom row is just a sample of a number of operators that are out in the wild today. These are built either by companies or different open source communities around these projects. Postgres, Redis, TensorFlow, Cassandra, Spark. There's a whole list of them on this repo called Awesome Operators in the Operator Framework org. And what you'll notice about these is they all have something to do with some sort of stateful data. And that's not by accident. It's not to say that you can't use an operator for anything stateless. It's very great for that. But stateful apps really show the power, because that's where you're going to actually need to do some logic around when failures happen, or when you're scaling the cluster, when you're deploying it, because you don't want to lose that data. So, for example, in a Couchbase cluster, when you lose a node, Kubernetes can faithfully spin up a new one. You'll get a new pod or a new stateful set. And the stateful set will make sure that your storage that was on the old pod gets mounted into the new pod. And that's great. That's step 1 to recovering from a failure. But you actually need to do something a little bit more complicated. You might need to rebalance the data. And in terms of Couchbase, this is required to get your replication back up and have a highly available cluster. And something needs to kick that off. There's no built-in primitive to Kubernetes to do that. So you can build that into the operator. So the operator will notice that one of your pods has failed, generate a new one, attach the storage, and then kick off that rebalance operation. And if you go to something like Cassandra, for example, and you wanted to scale out that cluster, you could use a pod autoscaler, for example, and an operator could configure and set up all that, and then You might change some of the replication mechanisms or configuration in Cassandra, and it would automatically go and reconfigure your ring and all that good stuff. And so this is where you can see that you start modeling these higher level applications with a really simple CRD, but it has really complex actions on the back end. And we see that folks running stateful workloads on Kubernetes are most successful in this fashion. So if you wanted to model your custom application, for example, is another great way to use this inside of an enterprise. If you think about all the things that, the knowledge that your team has and how they deploy their software, you can model that inside of an operator. So you can think about if you want to have move a version of your software between different staging production environments, that's now modeled as a CRD, and the operator does all the heavy lifting for you. One awesome thing to see in the community is the success that folks have had with operators out in the wild, and I wanted to highlight one experience for one of our CoreOS customers, Ticketmaster. They use our Prometheus operator, and they take a stance that all the dev teams can use the best tools to help them get their jobs done, and so they've got a number of commercial software that does monitoring for applications. But they also started using our Prometheus operator. And this kind of grew like wildfire as different teams were sharing their experiences, and now they're running 344 instances of Prometheus. And these are all managed by the operator. And there's no way that you could feasibly maintain 344 instances of this complex distributed monitoring application without having the operator there to do it for you. And the important thing is because these are using Kubernetes primitives, all 344 of these instances can live in their own namespaces. Those teams manage the RBAC and the permissions on those namespaces. These objects all fit natively into the Kubernetes ecosystem. You can use kubectl to describe their state and their status. Use kubectl edit to change configuration about them. And this is the power of using an operator. They're getting this cloud-like experience that you would get where you would say, I want a monitoring stack and I want it to be HA and I want it to stay up. And then you can run a number of those across a number of teams. And we think this is a really, really powerful validation of the operator pattern. And you see this all across the community using all kinds of operators that already exist today. So the reason that we've built the operator framework is because together with the community, we've learned how to make operators in the best way possible and avoid common pitfalls that you have. And the SDK encapsulates all of that knowledge because there's no need for everybody to reinvent the wheel. We've had 3-4 years now of experience thinking about this problem and then shipping and updating operators. And so we want to help everybody get started quickly. So that birthed the operator framework. And I want to describe the different components of it because each of them is important in their own right. So the two parts that we have today are the operator SDK. This is the build side of things. How do I build an operator, start modeling my application logic? And then the Lifecycle Manager. This is how do I instantiate operators in different namespaces, model their permissions correctly, and then get my applications that are installed by the operator running on the cluster. We have a number of other components that we'd like to add over time. These are things like helping you do metering for the operators running on your cluster. This is tracking things like resource usage and the number of operations that they're doing. So if you are running 300 of them, that you can start getting aggregate statistics of what's going on, as well as helping folks do things like license enforcement and just look at the number of objects that are being managed by the operator. So the first thing is we need to build an operator. So let's talk about how you would author an operator with the SDK. This is the rough workflow. The foundation that we start with on the left-hand side is some of the code generation that the operator SDK does. It comes with a command line tool that will instantiate a brand new operator for you. And this is going to set up all the primitives that you need to communicate with the Kubernetes API. And that doesn't sound that crazy, but if you've ever dug into the Kubernetes API and the Go client that it uses, there's just a lot of semantics that you need to know about how to communicate with it, how to retry failures for requests and that type of stuff. And there's really no need for everybody to be an expert in that. And we've been doing this for a long time, and we are the experts in that. And so we've encoded that into this foundation. as well as set up the entire logic tree and the loops and everything that you need to iterate over the Kubernetes events that are coming in. And that is where the magic of your application is encoded. As Kubernetes events come in for configurations change, this pod showed up, this node showed up, whatever it is, anything that you can see in the Kubernetes event stream, you can process with your operator and then take the appropriate action. Now, just coding that logic isn't all that you need to do. You actually need to have, reasonable certainties that local testing is going to work for that. So you can think about mocking out the Kubernetes API. So, oh, when this event happens or this scaling event happens, does my operator do the correct thing? And then also testing that against a live cluster. We've got some tools that are built in to help you run automation against a live cluster, and you can hook this up to your CI/CD workflows. This is to help you really feel really good about your operator because, these stateful databases are really important, for example, if that was the operator that you were building, and you want to have a lot of confidence that it's going to handle those failures in the correct way. Now, once you're happy with the version of your operator, you've got the logic encoded in it, you need to publish it. And we've got a publishing workflow, and what pops out of the other side of that are two things. There's an operator manifest, and this is some information about the custom object that your operator is going to be watching, some of the permissions that it needs, because the SDK knows what kind of commands that you're taking in Kubernetes if you're trying to spawn pods or edit secrets or whatever it is. So we've got some RBAC that gets generated for you. Then you've got the container image itself. And so the SDK will build that image, and then you can publish it on any registry that you like. We prefer Quay.io. And so those are what your end users need to run your operator on the cluster, is they need this manifest and they need the image. Now, I talked about this event loop, and I just wanted to talk through that for a second because it's really important. This is where you're bringing your application knowledge because you are the expert in whatever you're building. If you're building a commercial piece of software or if you're part of an open source community and you're building something like Spark, for example, you're the expert in Spark, and the SDK is going to help you kind of hook that up to Kubernetes. And so in that OODA loop that we talked about earlier, the operator is observing things from two different sources. One is the Kubernetes event stream, like I talked about, and you'll get that for free with the operator SDK, as well as watching for human changes to the custom resource definitions. This is the configuration of your application. So if you're going to change replicas from 3 to 5, the SDK will observe that, and then it needs to analyze what happened, look at the current state of the cluster, and figure out what to do. And that last state, the act, is when then new Kubernetes primitives or tweaks to your cluster are going to happen, and that's scaling the pods, generating secrets, changing config maps, whatever it needs to do. And just summing this up, so the goals for this are to maximize the opportunity that you have. So because all of this is kube native, you have the entire kube ecosystem to work with to distribute your operator, but you also have all of the Kubernetes primitives to work with. So if you've ever deployed a piece of software on-prem to somebody's data center, for example, you don't have things like autoscalers. You might have access to a hardware load balancer, but you don't have it all in the primitives like you do in Kubernetes. That's where it's really powerful to build these distributed systems. And then using the SDK, we want to minimize your effort that is needed to start with an operator, and then the pain required to either test it locally, to publish it, to not push out your first version, but your 3rd, 4th, 5th, 10th version. And then to really give just an image and a manifest to your end users, so to make it as easy as possible for an infrastructure admin to start running an operator. And as part of this, there are a few decisions that you need to make, and the beauty of this is they are yours to make. So you own the code that's produced by the operator, so if you want to make it open source, if you're part of an open source community, you can do that. If you're making a commercial product and you want to keep some of it closed source, you can totally do that as well. If you use GitHub, if you use SVN, you decide that. You can also decide where to host your container. So if you've got a container registry that's running internal to your organization, if you use a public registry, you get to decide that. And so really you have all the control in the world with the operator SDK, and we hope that it flourishes across the Kubernetes community for both proprietary software as well as open source software. Now, the other side of the operator framework is the Lifecycle Manager. And this is taking the outputs that are generated from the SDK, and this is what an individual admin or operations would have to happen on an actual cluster. And so what you would do is you take this operator manifest, and that's our declarative state with some of our roles and about our objects, and you would register that with a cluster catalog. Now, this is a concept in the Lifecycle Manager that's really important because the Lifecycle Manager is not just instantiating, one of these across the cluster. This is, with an eye towards a shared set of infrastructure that a number of different engineering teams are using. We see that as a really popular pattern for, having, 10, 30, 300, 1,000 namespaces on the cluster, and they can all have different versions of the operator. And an admin can even choose, with the RBAC primitives in Kubernetes, whether certain namespaces can instantiate that. So if you think about maybe running like a HashiCorp Vault, for example, in a Kubernetes namespace, Vault is a really important thing if you're storing secrets, and you want to make sure that the teams that are going to be running that application understand how it works, they understand the failure modes. The operator is going to help them through all of that, but it's important to understand what you're getting into. And so you might not want all your namespaces to have access to that. So the Lifecycle Manager helps you with that access control. Lifecycle Manager also helps you with the lifecycle of operators. So say you're working on your operator and you roll out a new feature that does better failure handling, or now you can scale in a different way. You need to roll that out to all of the consumers of that on the cluster. And the Lifecycle Manager helps you come out with strategies for how operators are updated. And an important part inside of the SDK is that operators are always forwards compatible. This is so that they can, have a live rolling update happen, and then the new version of the operator will start managing the old running instances. This is all the pods and config maps and everything that it manages on the cluster. And that's really important because you want these to operate in a cloud-like fashion where you're getting these new updates, whether it's, fixing something about the security of the operator itself, adding a new feature to it, or rolling out a new version of the application that is actually being operated. And the operator can have those smarts about what to do for that upgrade logic. So if you need to prime a cache, or you need to deploy one bit of the application before another different tier, the operator can do all of that logic, and the Lifecycle Manager helps roll that out to all the namespaces that are running it. And all of this, you can hear me talk about, there's all this automation in place in an operator, and we really believe that that is key to security. These days, especially running infrastructure like Kubernetes, it's fast moving. The cluster is highly dynamic, and the more automation you can build into it, the better you're going to have for end-user experience as well as security. And having Kubernetes be that source of truth for the desired state of your cluster, and that's things like access control, as well as different versions that are running across the cluster. And with the Lifecycle Manager, that's very easy to find. If I have a MySQL operator, which versions of MySQL are being run. If there's a new CVE in one of those, the operator knows how to upgrade them, and you can make sure that that happens. So this automation is key to running your cluster. Now, in OpenShift, we're very excited to be combining the best of both worlds from the CoreOS product Tectonic with OpenShift, and this is just a really brief look at what the architecture looks like. So you can see the operator Lifecycle Manager in the middle there is running, and that's going to be instantiating a number of operators across the cluster to manage some of these services, like I was talking about with etcd and Prometheus, as well as some of the built-in objects and services that come with the cluster, like the registry and logging stack and builds and image streams, all the things that you know and love in OpenShift. But there's also all this stuff beneath that that is actually the cluster's control plane itself. And we see automation key to security at every layer of the stack. And so we actually internally have operators that run across this entire stack that manage all of this. So the console that runs in OpenShift, for example, is managed by an operator. The different monitoring stacks, Kubernetes itself, all are operated, and this is really important because security doesn't end with your applications. It matters at the infrastructure layer as well, and even down to the Linux host layer. And so we're excited to continue our usage of operators internally and then see that flourish at the higher end of the stack for folks running these complex distributed systems in a really safe way that's really manageable at high scale, just like we heard from Ticketmaster with their 300 Prometheus instances. And we think this is going to give you the best developer experience for running those applications, as well as the best infrastructure owner experience for managing the cluster and the life cycle of all these operators that are running. That's all I wanted to cover with the slides, but we'll start with a Q&A, but I wanted to point out all of the links for the operator framework. This is an org on GitHub, as I mentioned. There's the SDK and the Lifecycle Manager, as well as some other tools in there, as well as our list of awesome operators. This is a list of all the operators that we know about in the wild, and a lot of which are open source. And so if you want to take a look at how some of those are built either with or without the SDK, that's a great resource. As well as in the GitHub org, we have a full getting started guide, which takes you full end-to-end of everything we just talked about. So doing code generation with the SDK, making a very simple sample operator, running that on a cluster with the Lifecycle Manager, and that'll show you kind of how you would start from code and then get to end user running on the cluster. So with that, I think we can start the live Q&A.
That's awesome. Thanks so much, Rob, for doing that. And I know you mentioned Ticketmaster before using the operators for Prometheus. I'm wondering, there's a bunch in the awesome operators, and I love the name of that repo group. And I think we have one of the folks who's done that, Mike from Couchbase, on the line as well with us today. And I'm wondering if Mike could talk a little bit about his experience, the difficulties, and I'll unmute you now, or the ease of creating an operator, and talk a little bit about that. Mike, the
Sure.
microphone.
Sure.
Go for
yeah.
it.
So when we started creating the operator, we actually did so before the operator SDK. And so one of the things that's really tough when you get started is just getting all of the, I call it boilerplate code in place that talks to Kubernetes. And so one of the things that's really nice about the operator SDK that Rob talked a little bit is that it actually generates a lot of that boilerplate code for you. And so we're talking about hundreds of lines. We had to do a bunch of research into figuring out exactly how the code worked, write it ourselves. And it probably took us 3 to 4 weeks just to do that. And with the operator SDK, one of the things that I think is one of the key features is that you can just generate all that code. And so instead of taking 3 to 4 weeks to learn everything and write it, you just run one single command. Everything's there. The project is set up the way that it's supposed to be set up. And you literally just have to add in a function that basically says, here's where I'm going to put all my code that actually, in our case, manages Couchbase. And so that I think is really, really helpful. It really allows you to focus on the stuff that you know, which is the application that you're writing your operator for. And then I guess just aside from that, operators have been something that's been really powerful for us at Couchbase. We build a database, and there's a lot of complex administration tasks around failure recovery, how we scale our clusters. And so operators give us a way to allow somebody who has no knowledge of how to run Couchbase to just have all that stuff automated for you.
So what is the update? Seems like it's a relatively new phenomenon in Kubernetes land. Do you have folks who are using this in production? Are you using this in production now, Mike?
Yes, right now we're currently in our beta releases. So we have probably 15 or 20 customers who are kind of testing it out, running it in their dev environments, and preparing to go into production. So for us, we're planning on having our 1.0 GA release sometime towards the end of the summer. And so we already have, I think, 5 or 10 customers lined up who are just waiting to go into production. And we've seen a lot of interest around operators just in general. A lot of people really wanting to use OpenShift and run their databases in OpenShift.
I also saw that because I do love the name awesome operators, and I'm going to say it as many times as I can. There's a TensorFlow one, there's a Spark one. I'm wondering, the demand for these things from a machine learning and AI workloads point of view. We have a SIG that talks a lot about that, and if that's where that's coming from, I noticed that two of the folks working on the TensorFlow one were two of the key members of the OpenShift machine learning SIG, and they hadn't mentioned it on the SIG, so I'm going to make them talk about it there. But is that what driving some of the demand as well as these really highly scaling workloads?
Yeah, I mean, I think any application that is complex to manage, it doesn't fit as well into kind of the Kubernetes framework. So Kubernetes basically has this model, in my view, where it's we're going to create pods. We have we have controllers that allow you to bring up pods, scale pods, and so forth. But really, when it comes to a lot of the more complex tasks, they don't really handle that. And I think that's the right model, because stateful sets and deployments, they really will handle 97% of people's use cases. But there are a lot of applications out there with heavy management where you can't just bringing up a bunch of pods doesn't really work, right? So in Couchbase's situation, if you want to create a 4-node cluster and you create a stateful set, it'll bring up 4 pods with Couchbase, but the pods won't know about each other. They won't cluster themselves together. And so when you start having to do things like that, I think operators are really powerful.
So there's still a lot of education to go on out there in Operaland. It's a fairly new framework, and I think it's going to be a very hot topic. And so we're going to try and set up an operator framework SIG coming up soon, and so look for that as well. There'll be an announcement around that, and we'll probably, Mike, try and get you and some of the other folks who've created operators to share your experiences there. So hopefully we'll get that spun up in the next day or so. Rob, is there anything else you'd like to add in terms of what people can do next?
Yeah, just check out the Getting Started guide. That's really the best overview of kind of how the whole thing works. We've got a public mailing list. It's a Google group. We'd love for folks to join on there and share best practices. We're also very active on GitHub, so we've got a lot more in store for the framework. We've got a lot of work going into both the SDK and the Lifecycle Manager. So look forward to folks getting involved with our community, helping out, filing bugs. So we're looking forward to working with everybody and helping make awesome operators.
All right. Well, thank you very much, both Mike and Rob, for your time today, and we look forward to lots more awesome operators populating that repo, so and talking about them more. So we'll definitely have some follow-ups as the framework evolves, and we'll get more information out there on blog.openshift.com shortly, along with this YouTube video embedded in these links and others. So thanks again, guys, and we'll talk to you all very, very soon.
Okay. Thanks for having me.
Thank you.